These are the solutions to 321, homework set number 1. On the first problem, I want to build an amplifier and a mixer. I want to mix two signals together, A and B, so that the output is 7 times A plus 3 times B. What these constraints tell you is just that it's going to be half volt in, meaning at worst 5 volts out. And in the audio range, just means use an op amp. Op amps are good to about 100 kilohertz. And the op amps are more than capable of driving 1 milliamp. So using an op amp, here's the circuit that will mix A and B. This has a weighting of 7A and 3B. So the output is the weighted average, 0.7A plus 0.3B. Times 10 gives you 7A plus 3B. And note for a times 10 multiplier, for non-inverting amplifier, the gain is 1 plus the ratio. So a 9:1 ratio gives you a gain of 10. On problem 2, if I want to drive an 8 ohm speaker, what I do is I take that output and connect it to a push-pull amplifier. These transistors amplify the current, so if I have 1 milliamp at the op amp, that'll be times 1000, gives you 1 amp at V4. The op amps are capable of about 50 milliamps, but not capable of 1 amp to drive a speaker. With the push-pull amplifier, I've taken a fairly wimpy op amp and powered it up, increased the current gain by about 1000. So this is problem number 2. If I simulate that, again, I'll take the summing junction, amplify by 10, run to a push-pull amplifier. To illustrate that this is working, I'm going to use 1 kilohertz sine wave for V1, 10 kilohertz for V3. And what I'll see is that V1 is times 7, V3 is times 3. If I look at the output at V4, what I see is the output is a nice clean sine wave. The low frequency signal is times 7, the high frequency signal is times 3. So that's your y equals 7A plus 3B, where the output is an 8 ohm speaker. Problem 4 says instead of driving a speaker, drive an LED, where I want the current to be proportional to the output. If I want 1 volt to be 100 milliamps, I'll use a 10 ohm resistor. That's a current controlled voltage source, also known as a resistor. Put the two diodes in parallel so that when the voltage is positive, or actually when the current is positive, the red LED turns on. When the current's negative, the blue LED turns on. And then I've got the current is 7A plus 3B, where 1 volt means 100 milliamps. If I simulate that, I increase the power supply to 15 volts to handle the 10 volts plus the LED plus the voltage drop across the transistor. At 15 volts this works, at 10 volts it didn't work. When the power supply is 15 volts, I see that sure enough the current, or actually the voltage across the resistor, which means the current, is 7 times A plus 3 times B. So that's homework set number 1 for ECE 321.